Alright, so here is the puzzle setup that I've got working. Um, there's actually a hidden object. You can see my foot standing on it. I've got to turn that off, but there's a hidden object there that kind of helps manage the connection between all of the things that you see here with red lights. So um, I've already got these configured for some solutions. Each one has a color, and each one has its own particular configuration that you need to put it into. Um, and to enter the puzzle, you press and hold E. Um, you enter the combination, and I've not built it yet, but there's an X key that you can press to basically exit out of the puzzle, return you to the third-person view. Again, it's all a process, but I'm just configuring these here to all be green. So you can see on the wall it's still red. These three have been solved as indicated by their green lights. And as soon as I finish solving this last one, the light on the wall should turn green. So here we go. That solves that one. And there you've got the green light on the wall solved. With the demonstration out of the way, kind of walk you through how I've built all of this. There's three particular items that you can see, and then one particular item you can't see, which is the blueprint interface that a lot of these actors are using to talk to each other. So the first thing I want to talk about is the relay object. And the way that this works is it's pretty simple. There are two variables that I've built out. So you've got target actors, which is an array, and source actors, which is also an array. So when you place this object or this actor in the game world, you have the ability to assign other actors to it. So over here in the details panel, you can see we have a target actor, which is the relay test object, which is the object up here on the wall. And then for the source actors, I've got each of the kiosks here. So kiosk 1, kiosk 2, kiosk 3, and kiosk 4. These are set up as pawns. So as you saw in the demo video, when you press E on the keyboard, you transfer possession over to the pawn, which is why you see these 4 cameras set up here. Unreal Engine 5 does a lot of the grunt work for you. You just basically simply tell it to possess the actor. And then when you press the X key, I've got it configured to repossess the BP third-person actor from the demo, from the included Epic Store demo. So basically the coding for this relay is done such that when it receives communication from the blueprint interface, and I'll go into this in a little in depth a little bit here in the short future here. There are a couple states, some that are intended to be used from a management standpoint, and then some that are intended to be used from the actors that are kind of participating in the puzzle. So this particular object is what I would consider more of like a manager, since it would be invisible, the player wouldn't see it, there's nothing for the player to interact with. It's just kind of there for a level builder to kind of place and configure without a lot of effort. So you can see here there are 2 events that are being looked at, which basically loops through the target actors. This is just basically setting the target state, and it can be inactive. You can set the state to active or inactive. This comes from the actual call of this event. So once the call is received, this particular actor will look at all of its target actors held in the array that it's configured with. It loops through it. It checks to see if it's implementing the blueprint interface. Again, I'll go into this a little deeper here in a moment. And then it basically checks to see if it does implement it. If it does, then it sets the state to whatever state that you've passed along with the event. Fairly simple, just basically kind of like I want to set all of the targets that are configured to on or off, and this can depend on what state your puzzle is. So if it's solved and you want to let your player fiddle around with it, and they can break the puzzle because they've kind of gone backwards and unsolved it, if you will, you can use this to basically turn the target actors to an inactive state. Refresh state will basically just give a very brief functionality for some actor that is configured as the source actors to basically, poke these objects and say, hey, there's been a change. You should reevaluate your source actors, and if there's a change there, go ahead and send that up to your targets. So fairly simple, not a lot going on here, but this is kind of like the wiring that connects it all. So I wanted to touch on this first, just so you kind of had an understanding of how this was all being pulled together. All right, so the next piece is the blueprint interface for how the relay is actually functioning. So let me go ahead and open that up. And the way that I've got this configured is there's 5 functions. The refresh is basically just a, hey, reevaluate type thing. No configuration for this really. It's just an interface that you will allow your objects to call to one another. No inputs, no outputs. It basically just lets the objects handle themselves, and you just basically get an interface to tell the object, hey, you should look at things. And that's kind of what it's meant to do. The set state accepts a Boolean active value. So if you want to set the state of another actor, this gives you an interface to do that. You can either activate or deactivate because it's Boolean. So this is more of like a one-off type scenario, but you can use this in a loop so that if you've got a collection of actors, you can use this to set the state for all of those actors. Of course, with a set state, there's also a get state. This is basically just the inverse of that function. So one-to-one relationship, you can say, what's the state of this actor? That actor would be responsible for, if there's a difference in naming for the variable that it uses to track active states. This allows leeway for that, so you don't have to always use like active or inactive. This gives you a little bit more freedom since, puzzles can get a lot more complex and you need more creative flex room to name things. So this allows for that. So the output for that would just be, again, a Boolean, whether it's active or inactive. And again, the actor is responsible for sending back what it wants the interface to know based on what state it's in. And then we've got the set targets state, which effectively wraps all of the targets that are, let me rewind a little bit. So the set state and the get state, those are for things that, these 2 functions are for actors that would be visible to the player in the game world, things that they can actually interact with and control. The set state, or the set target state and get sources state, these are things that a managing actor would do. And a managing actor, I kind of touched on this previously with the relay actor, would be invisible to the player, not something that they would interact with, but something that allows for configuration to connect multiple puzzles together. And you could have, instead of a light on a wall, you could have these 4 puzzles. They'd have to solve the 4 puzzles to open a door or something. But these 2 are essentially the same function as the set state and get state, but these are specifically aimed at the configured targets and the configured sources on that manager actor. And that's pretty much the blueprint. The blueprint interface. Very simple. I didn't want it to be something that was super complex. I am still learning, so this was just something to kind of test myself to see if I really understand the principles of what I'm teaching myself as I go through learning Unreal Engine 5. And next, I'd like to walk through. I'll probably save the kiosks for last because I think doing the wall piece and kind of explaining how I've got these set up with like a dynamic material is probably a little easier to explain with a simpler object. So this is called the replay test, which is just basically kind of like a little debugging actor that I created that I can just wire into a relay that just basically tracks active state. If it's inactive, it has a red light. If it's active, it's got a green light. And I've got this exposed to a checkbox, so this changes if you want to spawn it in and do something with it like that. You can. So let's take a closer look at this. All right, so this is implementing the interface that we just went over. There's one variable called active. Very simple. I just went ahead with the direct naming of active since I don't really have to track anything else with this. And the primitives I've just got built out as a black base box and 2 smaller boxes with a dynamic material assigned to each of them, which basically lets me control them as if they were like an LED. So very simple, just 3 boxes. I didn't do any modeling for this because I didn't want to fiddle around with that quite yet. But as we go through the different functions in interfaces, we've got the get state, which is basically just, hey, I want to know what your status is, and there's a return node that just sends back the active variable. Very simple. The construction state script will just do a refresh lamps call. And this is a function that is basically just a switch that looks at the active state. And then I've got 2 additional functions that I'm using to basically hook on to the primitive object. And there's some more functions in here. We'll do a deeper dive here in a second. So this turns the lamp off. And so in this case, if the case is true, if we're active, we turn the red lamp off, and we then turn the green lamp on. But if we're not active, we turn the green lamp off and turn the red lamp on. So very simple, not complex by any means. So these lamp off and lamp on, they both accept the object that you want to control. The lamp on will let you control the color of the lamp. So here's the lamp off. So the argument here is or the parameter is the object that you want to control, and that's being passed as we saw before. We're creating a dynamic material instance from that, and I have a material instance set up called kiosk key, and we'll do a deep dive here in a second to show how this works. I'll go over that with this piece. And there are 2 parameter values that I'm setting as part of this. So there's a parameter called emissive intensity, which is a float value. So we're turning it to just barely off, just a hint of it, because there's some color that will bleed through, which I think is helpful for just visual appeal. You don't have to do this, but that's just kind of a decision I made. And then there's the emissive color. In this case, I'm turning the emissive color to black to turn it off. And then once we update those values in the dynamic material, we reassign the material to the designated object, and it updates. The lamp on function works very much the same way. The emissive color in this case is something that you can pass in, so this gives us dynamic control of the color, which is helpful. So if we want to change color as part of the puzzle or something, there's freedom there. And then we're basically setting the emissive intensity to 1. So we're turning the light on essentially with this node. We're setting the color with this node, and then like the other function, we're assigning it back to the object. So very simple. So those are the two functions that I'm using in conjunction with the refresh lamps function. It's really helpful to use these internal functions for actors. Helps you really organize your code, lets you reuse large pieces of it instead of having these things, 4 copies of this on this blueprint screen. It just becomes visually easier to parse. So really recommend looking on YouTube or other outlets on ways to help manage your blueprints and make them cleaner and easier to work with. And that's pretty much it for this piece. The material that I'm using for this, let me go ahead and pull that up here. Oops, that's the instance. Let's take a look at the source material. I think that's helpful. So just a basic material. I've got metallic, specular, roughness, and anisotropy turned off. So this is just a float value 0. This is the off color. So basically, this allows you to control the brightness of the color. So the default value would be black. This is just kind of, as you would say, like hard-coded into the material. And this node here is the emissive color. So when you're assigning a color to the lamp, this is what you're controlling. You're controlling the RGB value, and you're assigning it to this node when you're working with the material instance copy. And then the emissive intensity is essentially being used as a blending float to determine how much of a mix between these two nodes that we're going to see as the emissive color. So that's essentially it. The base color is set to black. All we're doing is we're controlling the emissive color. This is just a very basic material. I'm sure there's ways that you could kind of expand on this to be more complex. But again, I'm new to Unreal Engine, so this is a big step for me personally, to understand how all of this works and being able to control this in an object. So again, this is really more for me to kind of test reinforcement of the things that I'm teaching myself. So if anyone has any feedback on how I can improve any of this, certainly leave them in the comments below. I appreciate any of that feedback. I'm fully willing to admit that this is probably not the best way to do it, but that comes with kind of teaching yourself. So look forward to hearing from anyone who's got insight there. But yeah, so this just gets assigned back to these elements here. That's the MI kiosk key, and that's the I've got a material instance set up so that any kind of changes that I make aren't affecting my base material, which is pretty standard for Unreal development. So again, I've got two of these lamps. One's red, intended to be red. You could have the same lamp. You could have one light if you wanted to and just change the color of the light. I just wanted this to be a little lower tech looking, just because I like that look. So, but yeah, that's the relay test. Just a nice, easy output for figuring out if the manager configuration that you've got set up in your level is correctly relaying the collective active states for all of the source actors it's configured to look at. All right, and the final piece is these kiosk puzzles that I've created. So one of the things that I want to talk about before jumping too far in are the controls that I have exposed on these actors. So some of these I actually need to turn off because I don't think they really need to have controls over here in the details panel. But it's easy to see here that we've got the return pawn, which is essentially the character. So this basically is tracking the pawn that the player was controlling before they entered the puzzle. So when they exit the puzzle, they go back to the same pawn. Very simple. Active keys. So what you'll see and what you saw in the demo first was the ring of the 6 concentric lines and then the outer ring of 6 perpendicular lines. Those are what I'm referring to as keys. And then we have a key color, which allows you to control the quote-unquote color of the kiosk, which is how you saw this one was white, this one was red, this one was green, and this one was blue. And then the solution, if you think about the hands on a clock, the inside ring starting at the 12 position is the 0 all the way to the right side of this series. So basically think of these as on-off switches, just a string of on-off switches. There's 12 keys and there's 12 bits essentially in this little binary string here, if you want to call it that. I can probably zoom in on this a little bit. So the topmost line here is all the way on the right and going from clockwise around. So you've got 11, 10, 9, 8, 7, 6. Then we jump back over here. This is 5, 4, 3, 2, 1, and 0. So 0 is the essentially largest number. If you want to digest this number down into a decimal number, I think it goes up to 4096 is what this binary could be transpiled as. And then we've got the active state, whether the puzzle's been solved or not. So those are the things we're keeping track of. Let's go ahead and take a closer look here. So there's a lot going on with this. This is probably the most complex piece of this entire arrangement. So starting off when play begins, we pull before I jump into the blueprints, let me go through the scaffolding of what we have in the viewport. So we've got a camera, and that camera is attached to a spring arm, very similar to how the third-person character is set up and designed to be controlled. Though in this case, the camera is static. You can't move around because it's a fixed object. That's just how I've designed it. And then we've got the collision box, which I'm not going to cover in this video, but this is there for determining when the little circular indicator that shows that you can interact with this object appears. That's a completely separate system. But just know that's there for that separate system. We won't go into that. It's not actually part of this configuration at all. But we've also got the green lamp and the red lamp that we saw from the other actor going through that. And then down here we can see the kiosk base, which is just basically the big, monolith-looking thing that everything's attached to. And then the 0 through 11, the 12 keys arranged on the face of the device. And that's essentially it. And each of these keys are also configured to use the same material that's being used to control the lights on the top. So again, a reusable component with several uses, which was kind of the goal for some of this. Going through the functions, we've got the construction script. Again, we're just refreshing lamps just to prime them and get them into a game managed state. There's a check solution function, which is pretty gnarly. This gets into checking the state of each of the keys, the active keys, any kind of keys that have been clicked on and have been added into the active keys array. This will loop through them and check to see if their states are active, and it goes through and checks the position of the bits. This gets pretty far into the weeds, but this is essentially the top level function for when you want to say, hey, something's changed. You should check to see if the player has solved the puzzle. Then we've got the get key index. What this will do is it will take the object and then it will get the object name, and then what we're doing is we're replacing the word key. So you can see inside the component list here, everything is named serially with key as a prefix, and then there's a number that accompanies the name. So each of these numbers corresponds to their position in the arrangement on the face of the device. So what this essentially is doing is it's stripping key and it's giving us a number. And that number is based on what we have named here. So this can break if you don't configure this correctly. I don't have any error correction built in place for this. So this is a bit contrived on my part. I understand the limitations of this and the implications of building a system like this. So again, this is just to reinforce the concepts that I've learned so far. If there's a better way to do this, again, drop me a comment. Let me know what the better solution would be. And then we're essentially just returning that number. And that gives us the position of the key that we're looking at. And then this one basically takes that position and then looks at the substring value. So basically whether its corresponding position in the binary string that I first showed, whether its active state matches whether it's a 1 if it's active or if it's a 0 if it's inactive. It does the comparison and says if it's the correct state, let's go ahead and say that it's solved. And this gets referenced inside of a loop. So as it's figuring out if you've solved the puzzle, it's looping over the keys, getting each index of the key, and then running this to check to see if that key has been solved. The lamp on and the lamp off are exact copies from the other actor that we went over, so I won't spend too much time on those. Again, refresh lamps, again the same, no difference there. Set hit component. This is where a lot of the interactivity comes from. So essentially what we're doing is we're converting a mouse click into world space. So this lets us turn, when we click on the screen, in pixels, and turning that pixel XY position into a world space coordinate, essentially. And it will also give us the ability to track which component was hit by that click. So imagine a laser being shot from the camera, and that laser going through objects. And what this does is it basically returns us the first object that gets hit. The laser won't stop. When it hits an object, there's actually a distance that is configured, and that's this value here. So I don't want it to go too far because you're already up on the puzzle, so it doesn't have to go too far. But this is casting the distance of that laser, going from the point of view of the player when they're in the little kiosk actor locked view mode. That's being shot towards the object in the direction of where they click with their mouse. And the first component that's hit by that laser comes back as the out hit. And there's a lot of things that we can grab onto here, but the only thing that we're really that we're concerned with here is the hit component. And what we're doing with the component is we're setting that as there's a local variable inside here that's just a reference to a primitive, and that's just the box that's being used to build those keys out. We're getting the return name, and this is just basically some debug text. So we could actually ignore all of this. This isn't really doing much for us aside from just giving us some helpful messaging on the top left for debugging. The end goal is to basically take what was being clicked, which is here, turning our mouse click into world space, firing a laser at it and figuring out what the laser hits, and then turning whatever gets hit into, or storing that and tracking that inside of a variable. So we'll use that later on as well. Let's see, that's set hit component. Is hit component a key? So basically, the previous function can be used and it will hit things that are not parts of the puzzle. This function is designed to figure out if it's a part of the puzzle. And that's essentially the whole goal of it. So the way it's doing that is it's grabbing onto the kiosk base, which is the parent primitive that all of the keys are nested under, which I'm using in this case is kind of like a filter. So essentially what this boils down to is whatever you click on, is that a child of kiosk base? And that lets me make a determination that if it's a child of kiosk base, I know it's a key because that's how I've got this built. And then from there, it just basically gives us some helpful debugging text, and then that passes whether it's true or false based on that. Pretty simple, just a reusable check. And then we've got a function here that basically says whatever that hit component was, is it active? Is it inside the active keys array or is it not active? So again, just a very basic, check here. Then we've got activate key, which will basically move one of these keys. Well, I don't want to say move, but it will add a reference to this primitive into the active keys array. And using the add unique, you can be sure that you're only adding one copy of that reference to that array. So you're not adding duplicates, which can, throw the puzzle off if you're not careful. And then once we have that added into the active key array, then we go ahead and turn the lights on. we turn the light on, and then we tell it to check the solution. Again, that was the first piece we went over, and then we have refresh lamps, which controls the two lights, the red and the green, on the top of the device. Same function for deactivate key, just the inverse. So we're removing it from the active key list, turning the lamp off, checking the solution, because what can happen, you want to check the solution again, because if you've got too many lights turned on and then you turn a light off and that becomes solved, you want to make sure that even turning a light off could possibly result in a solved puzzle. So we're running the check solution again, and then again refreshing lamps based on whether it's solved or not. And then refresh active relays. This is where it essentially radios back to all of the managing objects that basically says, hey, I need all copies of actors that are BP active relays. And that's going to return us either one or more, or maybe none, and this could just crash out, or not crash out, but because it's empty, it wouldn't execute this. If there's one or more, it goes into a for each loop and basically just says, hey, refresh. And that refresh function basically tells the managing object to say, okay, I need to check my source objects, and based on the state of those source objects, should I tell my target objects to also refresh? And that's essentially it for the kiosk. The next step is to make this so that when the game starts, it can actually randomize the solution for this, so that it's not something that's coded into or hard configured into the details panel. But I think what might also be useful is to add a checkbox that basically says, randomize this puzzle for each play. So that way you have full control over, should something be definite, or, maybe mix it up. Maybe you can have some puzzles that are definite, some that are random, and a little bit more difficult. But again, it's really up to what you want to build. And that's pretty much it. This has been really fun to work on. I'm really proud of the progress that I've made, just in teaching myself this, just based on some of the YouTube videos that I've seen out there. ChatGPT has also been pretty instrumental in providing me direction on, some of the concepts that I'm not familiar with, and being able to ask ChatGPT, hey, how do I do this? And it may give you something that you can't use. It may give you some bad code or something. But what I've found is most useful from it is that it will give me the correct terminology that I need to use to kind of hone my Google searching to a more specific, more industry lingoed set of search keywords, which has been super, super helpful, even in that respect alone. But yeah, so again, here's the demo again. I've just got this one configured to be the triangle, and then each of these other ones are the essentially points on that triangle. It's kind of like where I was thinking. There's that. And like I said, if you allow your players to, fiddle around with the puzzle afterwards and they unsolve it, it'll go back into an unsolved state, and it'll also tell the manager to say, hey, they just broke the solution. We need to reevaluate. So yeah, it's been a really fun journey getting this far. I look forward to being able to use more directed components, not so much just like test objects, though. I do kind of like the minimalist feel of these, though I'd probably remove the red green lights from the top just because those are more there for testing. But yeah, thanks for watching. I hope to be able to produce more of this kind of content in the future as I continue to learn. So thanks for your time.